Hi everyone, welcome to physics class. In this lesson today, we'll be talking about the graphical aspects of motion. The motions of a body can be illustrated with the aid of diagrams. Here we are going to be discussing the diagram to illustrate motions of a body. We'll be talking about distance time graph and velocity time graph. We have been encountering this kind of aspect of physics in our exam, most especially if you consider the past questions. It's very many in the JAM past question. So what do we need to know about all this stuff? Let's discuss it together. Let's start with distant time graphs. A distant time graph is used to describe the motions of an object and calculate its speed. Let's consider this graph here. The graph is plotted distance against time. When you are having the graph of distance against time, and we have a straight line, the straight line from 0 here that is further out, the gradient of this line is known as uniform speed. So whenever you come across, whenever you encounter something like this, you must consider the axis. Maybe it's a graph of distance against time before you consider your option. Now, as I said, let me repeat. Whenever you come across something like this, you need to check the axis before you consider what you are going to pick. The line here is a gradient which gives uniform speed. That is, this line is representing uniform speed. That is for this. Let's come here. When we are having a graph of distance against time, and there is horizontal line, straight horizontal line, the straight horizontal line shows the body is at rest for distant time graph. For distant time graph, we are going to test ourselves concerning all these things. We are going to consider past questions from JAMB in order to establish all what we are discussing, so that we have more in-depth knowledge about it. Let's talk about this. The graph is distance against time, and you can see it is curve graph. Curve graph. What is the meaning of this curve graph? When you are having distance against time, the object is accelerating. Is that possible? Yes, it's possible. Let's check this. Distance against time. When we have a curved line like this, the curved line, this is indicating the object is decelerating. Please master all these things. They are very good for us. Let's talk about velocity time graph. For a moving object, the velocity can be represented by velocity time graph. Let's look at this diagram. It's a graph of velocity against time. Just like what we have here. It's so similar to what we have here. And you can see here is distance against time. Here we have velocity against time. The gradient of this line, this straight line, is uniform acceleration. Look at it. Compare what is here with what is here. The most important is to check the axis. Check the axis. Here, when we have body at rest, is distance against time. Here, we can see for this straight line, it shows constant velocity. Constant velocity. Here is uniform retardation. You can see the slope is downward. The line is downward. It shows constant velocity. What is now left for us to do is to engage in past questions. Let's continue with that. God help us. Let's continue with this past question. Look at this question. If you look at this diagram, compared to what we have already discussed here, you can see this first part is similar to what we have here. That is uniform acceleration. ES is for constant velocity, and that other side is uniform retardation. From this question, we have to calculate the total distance covered. We are asked to calculate the total distance covered from this question. We are given acceleration, we are given the time. Let's do it together. Let's challenge the question together. Let's do it together. Let's do it together. The figure below shows the velocity time graph of a car, which starts from rest, is accelerated uniformly at the rate of acceleration. The values of acceleration is equal to 3 meters per second square. They are given. During the acceleration, it spent 5 seconds. For 1 minute, that is 60 seconds, and decelerate for another 3 seconds. Let me explain it better. Here, during the acceleration, we are given the values of the acceleration. During the acceleration for 5 seconds, we have the uniform acceleration. For 1 minute, that is 60 seconds, there is constant velocity. For 3 seconds here, the car obtained deceleration, and we are asked to calculate the total distance covered from this graph. The total distance covered is equal to the area of this graph, and the shape of this graph is trapezium. If you can remember the area, but before we can calculate the area, there is something that is necessary we have to do very fast. We need to determine the value that is here, the height. That is, we are giving acceleration and in this time. So to determine the velocity is so simple, and the body start from rest. Initial velocity is equal to 0. Our final velocity is what we want to calculate. Therefore, we can say acceleration is v minus u over t. Acceleration here is 0. V. So let's make v the subject of the formula. V is equal to 80. V is equal to 3 multiplied by 5. V is equal to 15 meters per second. Here, where the velocity is maximum is 15 meters per second. So we can now calculate what they ask us to do. Let's calculate the total distance traveled. As I said earlier, the total distance is equal to the areas of the graph. The area of the graph is half into bracket AB, the line AB plus the line OC. AB plus the line OC multiplied by the height. We can say AE, which is equal to the total distance. From this graph now, AB, the space between AB according to the time that is given here is 60 plus 0 to this will give us 68. Height is 15. Distance, this plus this will give us 128. 128 multiplied by 15 divided by 2. It will be 1920 divided by 2. Total distance will be 960 meters. Do we have 960 in the options? Option D is the correct answer. Thank you for listening. God bless you.